So now we know what a function is. We know how to define a function. We know how to use a function from the command line in MATLAB. One point I want to extend on is the concept of workspace. That's being a private workspace for a function, and also an associated concept of variable scope. To point these features out, I've got the same function that we had last time with the input of a mass vector, or a mass array I should say, with the output of the force array. But I've inserted some breakpoints, and I've also put in a little line at the end purely for the purposes of me allowing to put a breakpoint in at the very last step of the function. So now if we go to MATLAB, we see an empty workspace. So let's create some sort of set of numbers to chuck into our nice little function. Okay, so in the default MATLAB workspace, we now have a variable called m, which I'm going to feed into ForceCalc by calling the function. And this function is going to be called, and it's going to be initialized in memory, and in this memory the function is going to have its own private workspace, which is distinct and separate from the default MATLAB workspace. So to actually see this workspace, I've set up the breakpoints, and now we're going to dive straight into it. So I've called the function, and we see the K. This means we're in debug mode. The function's been called, it's executed the few lines at the start, so now we have G, and force has been constructed, which is the 0 array, and we also have the input that we've passed. Notice how the input now, before I called it M, but notice how it's actually called mass. This is the name of the variable used inside the function. So you can actually see now, since there's no variable m, we've actually moved inside the private workspace of this function. So we've stepped inside of the black box that is a function, and now we can actually see how it works. Okay, so these are all the private variables to this function. And now we say these variables have local scope to the function ForceCalc. Okay, so these variables are local to ForceCalc. They're not accessible anywhere outside of this function. So they're not accessible in the default workspace. And if we had another function somewhere else that we're also running, that function cannot access these variables. These variables are local, and they're local to ForceCalc. Okay, now a local variable is the technical term. That's something you should get used to. So now we're actually inside the private workspace. Let's see what's happening. Let's just step through one step. So you know, the local variable n has been created. And now we're just doing the same old things as we did before. We've computed the first value of force. Let's have a look. The first value has been computed. Something's been printed to the screen. You know, all well and good. So now I've clicked continue, and where we left it, the for loop has kept iterating over the four elements in mass, and for each one the value of force has been calculated. Okay, and the associated code with displaying it to the command line has been executed. And now we've exited the for loop, and we're at the very end of the function. So the function's done its job, it's executed the code, it's done our calculations. All the private local variables, such as force, g, mass, and n, they've all done their job, and here they exist in the private workspace. Now we're at the very last line of the function. So we're still in the private workspace and we're just about to exit the function. So what we should expect is that now the function's finished, it needs to go back to the workspace that called the function originally. In our case, we're operating from the command line. So if we're in the command line, we're in the default workspace. In that workspace, we've defined the variable m. We've used that variable as the input to force calc, and the private workspace of force calc was calculated. The private workspace of force calc was created, and inside of the private workspace, all these local variables have been used. Now we're just about to exit the function, so let's see what happens now. Okay, so I've continued, and I've left the private workspace of the function. The last line of the function has been executed, and the output of the function has been printed. It's done this because I left off the semicolon on the function call. So if I used a semicolon here, I wouldn't be seeing this output. So you'll notice we've left the private workspace. Now we're back at the command line. We're back in the default workspace, and we're back where we started. So we had m in the default workspace, and now we have the new variable f in the default workspace. Now f is the output of this little function here that we've made. And so that basically demonstrates the concept of a private workspace. Okay, so you need to keep this in mind when you're writing your functions. That is, a function and its variables have its private workspace, and the variables that inside the function are only accessible by that function. They're not accessible by any other function. And this comes as a good thing, because it avoids interference between workspaces, and it avoids us overriding certain variables and getting dodgy data. But at the same time, you need to be aware of this, because if you want to use some similar variables throughout multiple functions that you may be writing, you need to make sure that each variable that you want to use inside a function is defined in the function, or otherwise it's passed into the function as an input. So if I had a bunch of similar force calculations, each using the acceleration due to gravity, I need to make sure that each function has this line defined in it. Otherwise, if I go to run another calculation using, I want to use g, and g isn't defined, it's going to spit out an error, because in the private workspace the variable g doesn't exist, and so we can't use it. So the main point to take away is that there's private workspace where all the functions variables are local, and only that function is allowed to touch them. No other workspace outside of that can touch them. And so that's about it. The idea of separating these workspaces, this complements the idea of modularizing a program. As we said before, that's breaking down a larger problem into many smaller ones, where each smaller problem, each function is independent of the others. Each function is a black box with its own operation, with its own variables, and each of those variables has its own local scope. Okay, so keep this in mind as you write your own functions, and yeah, good luck.